Hello everybody, this is the notes for section 13.2, second section of the trigonometry portion of Algebra 2 trig class. Pardon me. As it says down here in the bottom, you're going to want to look at page 836 for the full definitions. I'm just going to kind of talk about them in the picture, but what we are referring to here is the standard position for an angle. All right, in the first section we talked about just right triangle stuff, just here's a right triangle and here's how you relate the angle measurements to the side lengths. Now, we're going to take those angles, those triangles, and put them into the coordinate grid system, the x and y axes. So, the standard position for an angle theta. Basically, the vertex of the angle is going to be at the origin. The angle, the initial side is going to go right here on the positive x-axis. And the other end of the angle is called the terminal side. So that can be anywhere. Does not have to fall into a right triangle. We're going to form a right triangle, but we're just talking about any angle measurements, okay? You know, section says angles of rotation. So basically, the positive x-axis, that is our 0-degree mark. If we rotate counterclockwise, those are positive angle measurements. If we rotate clockwise, again, from the positive x-axis, those are your negative angle measurements. You go all the way around the circle, that's 360 degrees. All right? So, first main term is called a coterminal angle. Basically means you start at the same position, which is on the positive x-axis, that's that initial side, and you're going to have the same terminal side of the angle measurement. Okay, they're different angles, but you're starting in the same spot and you're going to end at the same spot. So basically, you're going to go around the other direction. So if we look at this 90 degrees, you know, the question says find the coterminal angle theta for each angle below, such that theta is between negative 360 and positive 360. So here's my x-axis, y-axis. We are starting here at 0. And we are going up to 90 degrees. So the coterminal angle, well, for it to be between 0 and, or between negative 360 and positive 360, we can't go all the way around. That would be 360 plus another 90, so 450 degrees. Would not fit with the requirements of the problem. So what we need to do, get rid of that, is go negative. Now, there are a couple formulas, you know, take it away from 360 or 360 minus this number. I don't like memorizing those formulas. I'm just going to use my references. Okay, one, I'm going in the negative angle direction. So I know my answer is going to be negative. There's the negative 180 mark. We want another 90. So negative 270 degrees. 90 degrees and negative 270 degrees. Those are coterminal angles. All right. Negative 210. First thing I want to do is just see where that is. So it's a negative, so I'm going to start here at the positive x-axis at the 0-degree mark. 210 degrees in the negative direction. If I go to here, that's 180. That means I got to go another 30. So this is a 30-degree angle right there between the angle and the x-axis, the negative part of the x-axis. But that is my negative 210. So the coterminal is going to be the positive one. Well, again, you got a couple ways to think about it. But if this is 30 degrees here, that means that was 60. So I went 90 and then another 60. Positive 150. Okay, they are not equal angles, but they are coterminal angles. They start and end at the same place. For the 530-degree angle measurement, x and y axis, it's a positive angle. So you go all the way around the circle, that's 360 degrees. I gotta do some math here. 360 plus another 90 is 450. So that means we need another 80 to go. So basically it's right there. This is 530 degrees, where we had to go all the way around, past the y-axis one more time, to and then another 80 degrees. So the coterminal angle between negative 360 and positive 360, we've actually got two of them. The first one, staying positive, but staying between, or staying less than 360 degrees. 90 plus 80, 170. The other one is the negative. Negative rotation, so we're going clockwise, 180 plus another 10. So a negative 190. Where the 10 came from, if that part was 80, this part has got to be 10. Okay, big terminology. Definitely need this. This is probably the most important thing in this section. Well, it's not the most important thing, but it's the most important thing to allow us to do the most important thing. It's called a reference angle. Basically, it's the angle formed between the terminal side and the x-axis. It's an acute angle. It's a positive acute angle. So, just as a very basic example, I don't even want to do these ones yet. Let's just look at 150 degrees. So, when I put that angle onto the XY grid, 150 degrees is right here. All right, goes 90, and then another 60 degrees. So, the reference angle is the angle formed between the terminal side and the closest part of the x-axis. So that's this red angle here. That's 30 degrees. So this is my reference angle. It's 30 degrees. That's the one that we're going to be dealing with most of the time. All right. The problems that you'll see in a little bit, they're going to be asking you, what is the sine of 150? Well, you can just use that reference angle of 30 and get the answer. Okay. So just let's do number 7, negative 120. Let's put the angle onto the grid. Negative 120 degrees. That is going to put us negative 90 plus another 30 right here. So now the reference angle will be in blue from the terminal side to the x-axis. 60 degrees. We had to go 90 and 30 there to get to the 120. And then there's another 60 to go to get to the x-axis. So 60 degrees is the reference angle. Okay, this is going to be the last part of the notes for this video. This was in your textbook also, but copy all of this stuff down, including the picture, all the formulas, everything. And please watch the second video to see how you deal with this stuff.